All right. And we're live. Hello. All right, let's get started. So, let's grab the old Tabliono. Here we go. First stream, just gonna do physics problems till our heart's content here. All right, a constant horizontal force F is applied. Oh wait, let's get some music going here. Let's get a little bit of music. Just a little bit. Just a little bit of music. Alright, I've actually been listening to might be a little bit loud. There we go. Nice. Okay. Beautiful. All right, so you can go back in time anytime and take a look. And we'll also have the PDF from our work here today. I actually might stand up. I got a little stand-up desk here. Sorry, starting a stream. We're not even set. We're not even ready. It's all right. It's the first one. Oh. All right, we're standing now. Just about ready here. Right. The chair. Right. So we got to draw a free body diagram. What are we asked to do here? This. Okay, that's pretty good. Alright, so draw free body diagrams for each of the blocks. Okay, so we've got a block. Let's maybe call this, we'll call this 2 and this 1. Okay, so let's make that official. 1 and 2. Okay, so let's separate them a little bit here. Let's just make some free body diagram boxes. So we're going to make a free body diagram for both of these. So M2. What are the forces that M2 feels? Well, M2 is on Earth, so it feels gravity. Straight down. Okay. Because it's not moving vertically, there must be something opposing that FG. And what is it? It's the surface. But that's not the only thing opposing it. We also have some force coming from M1, but let's not go there yet. Let's talk first this FA. I'm going to call this FA. FA is F applied. So F applied is to the right here. Do we know what F applied is? You'll notice I haven't even really started reading the question. I just immediately jump to what's asked of us, and then that I'll use that to inform kind of how I read the question. Okay, but let's even maybe jump to M2 and do some of this, sorry, M1 here. It's weird that the one on the right is 1 and the one on the left is 2. Okay. So, M1. What sort of forces are M1 going to feel? Well, M1 is also on Earth, so M1 is going to feel gravity coming straight down. All right? So, let's make that a fish here. Boom. Gravity. Okay. So let's, because those look like the same gravity, so let's label them appropriately. Let's call this one FG1, let's call this one FG2. Because that one belongs to M2, this one belongs to M1. Okay, so does M1 know about or feel FA? Does M1 know about or feel FA? No. No, no, no. For all M1 knows, there's just a push coming from M2. So FA will sort of translate to change this force that M1 feels. But what sort of force does M1 feel? Well, you know, this is maybe something that we can kind of approach here. Are we comfortable saying that that will be the kind of, you know, it will either be up and to the right or down and to the left, right? That force in how we see that force, right? So, well, let's think about it a little bit more deeply. So M1, what sort of forces, if you were M1, or if you want to, if you were M2, if you were M2, you would feel something kind of coming down on top of you. That means it's coming down, its force is down on top of you, but it's not only down, it's down to the left. So M2 feels this force, which is, let's maybe label it here. Let's call the force of, are these blocks? Yeah. Okay, so let's call this the force of the blocks. Okay. And the force of the block, the force from block 1 onto block 2 is the same as block 2 onto block 1. So this might seem like a silly thing to have to highlight here, but what this is Newton's third law, that if I push on the wall pushes back on me. Right? So if this mass pushes with a certain force, the other it gets pushed back with the same force. Okay? Okay. So then actually wait, let's just do a little tech check. Okay? Tech check. Pause here. Tech that check. If I push on the wall pushes back on me. Right? So if this mass pushes with a certain force, the other it gets pushed back with the same force. Okay? Can y'all not hear the music? Can y'all not hear the music? Can y'all not hear the music? Um, hmm. Second here. Block. Oh, you can. It's just crazy quiet. Okay. Okay. How's that now? Those better levels? Are those better levels? Let's try it. Okay. Sorry, another tech check. Oh, you can. It's just crazy quiet. Okay. Okay. How's that now? Those better levels? Are those better levels? Let's try it. Okay. Sorry, another tech check. Okay. I think we're okay, right? Not bad. All right. Okay, let's do that. All right. So, okay, so where were we? We were just figuring out forces on these two masses. So M2, we just figured out that M2 is going to feel that force down and to the left. Okay, and it's going to be equal to the force on M1. And how's M1 going to feel? It's going to feel something coming up from below it and over to the right. It's going to be the opposite. Okay, equal and opposite. So there's that force there. And that's we're going to call FB. We're allowed to call them both FB because unlike FG, they are different for each one. Right, in FG. So we have to put the 1 and the 2. But FB, it's the same for both. So we can get away with just calling it FB. Okay. So we're almost done here. Let's keep looking at the forces on M1. Okay? Because M1, and like remember, when the well runs dry in terms of figuring out which forces are where and what forces are present, we can use the motion. So if something is moving to the right, the forces should kind of end up pointing to the right at some point, right? When you have them all. So if you're sort of like running low on forces and it doesn't point to the right, you probably need one that's going to the right. Okay? Okay, so let's come back to M1. M1 feels gravity downwards. Okay? It feels FB up and to the right. So that means there's and remember, this is a key part of these questions. We're going to turn this into two vectors here that will be FBX and FBY. Right? And that's based on the triangle that it's in, and we can kind of do that separately if we need to, but should be relatively, this is a university mechanics course, so we should be comfortable breaking things into components, and it should be relatively instinctual. Okay, so let's do that. This is FBY. This is FBX, and together with our old Greek friend Pythagoras, make up FB. Okay, so we're going to break down FB into FBY, FBX. We're going to be able to sort of equate them on M1 and M2, but we're still not done on the forces on M1. So there's another force here, which is, and you can use M2 as a clue. There's no applied force, so we agreed that, M1 might feel the effects through FB, but there's no direct FA onto M2. There's no direct applied force onto the block on the right. But what there is it's being pushed up against a surface, so that surface has to push back. So we're going to see our old friend Fn. Let's maybe not put that in green, let's put that in. And this one's going to be particular, so this one now we should call Fn2, this one we should call Fn1. Okay? And that's about it. Those are all of our forces. Okay? Now, the question is, do we have friction? So it might be worth reading the question now. At a constant horizontal force, F applied to a mass, M2, okay, so they tell us it's 3, which is in constant contact with another mass, okay, we can see that from the diagram. Okay, 5, we can see that on the diagram. As block M2 moves horizontally to the right with A2, okay, wait. Block M2 moves horizontally to the right with okay, so we know M2's acceleration. So this thing is accelerating 0.5 meters per second squared to the right. Okay. Block M1 moves up vertically. Ooh, okay, so what did they tell us? They told us the acceleration is this way, right? Which means Fnet is also in that direction, right? And that's on M1. And this one here is true of M2, that Fnet and A should be to the right. And all contact surfaces are frictionless, so that answers that question. Okay? So we're ready for it. So we've got free body diagrams for each of the blocks. We maybe would break this one down into these two components. Okay, so I might add that here, just sort of say, and put these in dotted so that they don't get confused as like new different forces. This is just FBX and FBY. Okay. Okay. So we should get all 6 points there. Okay, B, find the acceleration A1 as a function of A2. A1 is a function of A2. Okay. So, sorry, just give me a second here. Okay. So, okay, find the acceleration A1 as a function of A2. So we're going to have to start to bring these together. FB is going to be our connection. I think that's about it, right? So, okay, so let's start to do it. So, let's do this. Let's put this here. Let's do FNet2 is M2 times A2. So we can actually calculate what FNet2 is. We have M2, it's 3. And, okay, so let's actually maybe do our inventory here. Let's do it. M1, A2, A1, we don't know. Huh. Wait, we need to find the acceleration as a function of A2. Ah, we need to relate the two accelerations together. I think, actually, this is, we're just going to be able to do this using geometry with 30. So, just give me 1 second here, let's just get these down. 3 kilograms. Okay. So, okay, so if we think about this here, for every, let's say for example that this thing travels for 2 seconds. Okay, so we actually get a delta D. Let's say that it starts from 0 and it moves for 2 seconds, and we get a delta D of what? Half more. So we get a delta D of 1 meter. Alright. Okay. So what would it be with the triangle that we have there? So this thing is going to move this distance by 1 meter, and this thing has to move up. Well, it better be congruent, or at least sort of like coming from this triangle here, right? So for every amount that this thing moves to the right, this thing has to move up by the kind of, you know, proportional amount, right? And we can use that triangle there. We can say so this is 60, this is so for every 1 meter that we travel here, that will sort of be our amount that we travel in that dimension, and we know this is 30, so we can do the tan of 30 is delta D2, nope, sorry, delta D1 over delta D2, opposite over adjacent, and so that should also be the proportionality here. So that might even be our answer there. Tan 30 which is what? 1 over root 3 is a1 over a2. So find the acceleration a1 as a function of a2. So a1 is equal to a2 over root 3. Boom. Boom. Okay. Let's keep it moving. Find the magnitude of the force F. Okay, so FA we don't know, so we kind of have to go now into this world anyway. So let's do it. Those here. Just move this down. Okay. So let's Dewey Decimal here. That's right. Okay, here we go. Okay. So Fnet 2, we know the mass and we know the acceleration. So we should be able to say that that's, oh my gosh, 1.5 newtons. Okay, and the Fnet here is going to be purely horizontal, so it's only going to be in the x, and the Fnet y is going to be equal to 1.5 newtons. Right? That's what we can kind of draw from our diagram. This thing is not, oh, whoa, the other way around. Oops-a-daisy. So it's not going to be moving vertically, but it is going to be moving horizontally, so there is an Fnet in the horizontal, but not a Fnet in the vertical. Look how ugly that net is. Come on, brah. Come on, brah. You better net. You do better nets than that. Boom. Okay. So this looks like 15, so let's make that 1.5. Okay, so let's do it. So what goes into Fnet x and what goes into Fnet y? Well, let's start with Fnet y because it's 0, so we're probably going to use something there and go into Fnet x. So Fnet y is 0, that means Fg2 is equal to Fn2, and Fg2, there's also a Fby. Those two are in the same direction, and that's equal to Fn2. Okay, so then M2G plus Fby we don't know. Fn2, we don't really know that either, actually. Okay, so let's maybe then go into our x. So in the x direction, it's only Fa, and we're going to actually subtract Fbx. Why are we going to subtract Fbx? Because what direction is it moving? Let's make that the positive direction. So it's moving to the right. Let's make that the positive direction. Fbx is to the left, so that's negative. And we know that it's going to win by 1.5 newtons. Right? Okay. So I think what we'll need to do here is use our Fbx, Fby from our M1 and relate those to sort of say something about Fbx and Fby in M2. So let's get there. So here we don't yet know the Fnet, but we can soon find out, because remember A1 is A2 over square root of 3. So this is 5 times 0.5 over the square root of 3. And so what do we get? What do we get? 1.44. Now, does that make sense? I'm comfortable with that. It's not crazy compared to the other FNet. Nothing wild happening, right? Okay. So we've got an FNet. Not bad. What is the FNet X, FNet Y scenario for M1? Well, in the X direction now, it's 0. And in the Y direction, that is actually your 1.44, right? It's purely in your Y direction. So let's do the same kind of thing. Let's sort of talk about FNet X, FNet Y. So, FNet X, we have FBX is equal to FN2, right? And so this thing is going to be moving up. So let's make up positive. And those are the only two things present. And so now I think we have enough to start to solve here. So let's solve kind of what we can. So this we know, so that whole thing we'll be able to find. FN2, wait a second. This is 1, not 2, sorry. This is 1. Okay. Okay. So yeah, let's start to sort of like sub some things in. So this we can solve for, what's that, like 29.4-ish? Is that right? Yeah. Something like that. Okay, we might as well do it. Jeez Louise, we might as well do it. Times M1, so that's 3, so yeah, 29.4. Oh gosh, why did I put out myself? Okay, so we don't know any of those others, but that's at least an equation we can kind of take forward. Okay. The other one we don't have any other information for is this one, but those two are the two things we're going to bring forward. Okay. Okay, so let's do it. So this one here, do we have anything to add to that? I don't think so, so let's just bring that forward, but it's nice because those are FBXs, those are the same FBXs. This one here, we have some things to add here. We know FG1 because we know M1, right? And G, we know it's on Earth. So let's do FBY minus M1 times G. So we get 49.1, and that's equal to 1.44. We now can solve for FBY, right? So what is this? Plus 1.44? So we get 50.5, right? Newtons. And now we have FBY. Well, if we need to get to FBX, remember we also have the relationship that they were born in, right? So we can use tan theta and FBX, FBY and rearrange. So we now have FBY, right? So let's use the tan of 30 and let's just make sure we get it right. So tan, because it's opposite and adjacent, but who's opposite, who's adjacent? So tan of 30, the opposite is FBY, and it's opposite over adjacent, so it should be y over x. So tan 30 is FBY over FBX, and so we can do some rearranging. FBY, no, we already have FBY, we want FBX. That's equal to FBY over tan 30. So 50.5 divided by 1 over root 3, mate. We get 87. So let's say 87.4. Or let's just say 87. Let's give it 3 seconds. 87 points. Okay. So those are equations that we can kind of bring forward with us. And now we should be able to go back to the other and solve. Okay, so this. Achieving something worthy's got my mind boggled, and now I'm feeling topsy-turvy in the state of depression. To be a weak expression that's got to go with no flow. So now you learn the first lesson. Check it. MCs, you're getting nothing this way. When we up on the mic, you know you best to parlay. I got my brethren, everything's okay. Respect to all the monster rock, I'm off and sim with one time. MCs, you're getting nothing this way. When we up on the mic, you know you best to parlay. So we get FBX and FBY, so let's go back. So now we know FN1. Do we really need to know that? No, what are we even after here? We're after FA, so let's use that equation. We can find FA. So FA is equal to 1.5 plus FBX. FBX we said was 87.5. Interesting way to write that. So what do we get? 89 newtons. 89.0. Boom! Not bad. Okay. Keep it going. Keep it going, bro. Keep it going. Okay. So, solid ball of mass M is attached to a vertical rod via 2 thin strings of identical length L. As the rod rotates around its axis, the ball executes uniform circular motion with speed v. Okay. The upper string makes angles there. Lower string. Okay. So, this is interesting. Okay. So, okay, we don't know what theta is. Draw a free body diagram for the ball. Sure. Okay. So, free body diagram, square. Give me that square. Give me that rectangle. Okay. Beautiful. Boom. That's your M. Forget about it. Okay. It's on Earth. Forget about it. It's got a string pulling it up and to the left by theta. So let's call that T1. And it's also got one, I'm assuming this is kind of like an isosceles. That's also theta. And that's pulling at a T2. Is that it? I think that's all the things you're going to experience, right? As M. Are we going to experience a circular force of FC? No! FC is not a real force, it is a net force, right? It's a circumstance of net force. And that's something that we're going to use for sure. So F net is equal to mv squared over r, right? If you're not comfortable with this, then talk about it, but so we should be able to kind of like find this, right? It's r value, and that we can do with just this triangle here. So that's theta, that's L, that's R. So what's the relationship between those? Well, those are the hypotenuse and the adjacent of a right angle triangle. And so adjacent hypotenuse, that's K. So then the cos of theta is equal to R over Or we should be able to say mv squared over r times L cos theta. That is our F net. Okay, so then, well, wait. Did we draw a free body diagram? Yes, we did. Let's kind of like, I'm now maybe just getting ahead of myself, but I'm assuming we're going to have to do some forces about this stuff. So find the ratio of the tension. Okay, sure. The tension forces act upon the upper and lower string and applied to the ball. Find the ratio of the tensions. Okay. So ratio of tensions. So, okay. The ratio of the tensions. That's interesting. Okay, sure. So, to get here, we're going to have to do some F-net stuff. So, let's do it anyway. So, FG, well, let's maybe just say that this is also purely horizontal, right? So this is X, because this thing is moving in a horizontal circular motion. So F-net Y is 0, which means, you know, FG plus T1X plus, sorry, well, not X, but Y plus T2Y is equal to 0. But that doesn't really account for the positives and negatives. So let's do that ourselves. Let's say that if it's 0, that means they kind of cancel each other out. So who's on one side? It's FG and T2Y. And that's going to be equal and opposite to the one thing that's pulling up, T1Y. Okay, so that's the equation we can get from the vertical. Okay, so let's go to the horizontal. We know that that's our F net value, but what are the forces that are going into that? Well, there's a T2x and a T1x. Are those the only things? And are they going in the same direction? Do we have to worry about negatives, positives here? They're the only things moving horizontally, right? They're the only forces. So we're fine. So, okay, so let's do some rearranging then, right? Remember that T1x is related. How is it related to T1y? Well, you know, for either of the T's, right? We're going to be able to kind of come up with a right angle triangle. That's a T. That's Ty. That's Tx. That's theta. So tan of theta, oh, not theta 30, but theta is going to be the thing that relates our Ty opposite over adjacent. So this is true of both 1 and 2. Okay. So let's kind of now start to bring these together. So we see T2x. How about we kind of turn those things into T2x equations, because we already have a T2x equation that uses our L and our cos theta and our M, right? This one here doesn't really use all those. So let's turn our T2y's. So I want to kind of solve for T2y here. T2y is T2x times the tan of theta, right? Can you see that rearrangement from here? To solve for the y, we multiply both sides by tan x, and it shows up over on the left side. Okay, so that's the same thing for T1y. And the theta is actually the same, so we're nice, so that's good. Okay, so let's say that FG plus T2x tan theta is equal to T1x tan theta. Right. Okay, so I think it's about time that we sort of start to do some ratio stuff. So something we could kind of do at really any of these stages is if we were to do a ratio at this stage, right? Then we would be doing like T2y over T1y, right? Which is equal to the T1x over T2x, which is equal to T2 over T1. This is the ratio, right? The tan thetas cancel, but either way, it's a, they're sort of proportional triangles, right? All the ratios are the same. Okay, so what that means is if we can kind of like just solve for, let's say we sort of divide these two things over each other, right? And we just turn that right side now into something that we can solve for using these two equations, then we should be okay, right? So let's do that instead. Let's do T2y over T1y is equal to T2x, and that will use this, and times tan theta, right? And obviously the tan theta is kind of canceled here. T1y, and for that we're going to use this. Okay. So let's do it. So here we already have one kind of ready to go. So this is going to be FG plus T2y all over, well, T2x. Let's actually maybe turn that into something with T2y, because we have a T2y on the bottom here, right? So, so T2x, if we were to sort of rearrange this to solve for T2x, it would be tan 2y over tan theta, right? So let's do that, tan 2y over tan theta. And now we can do some work. Wait a second, can we? Oh yeah. Okay, yeah. So actually, we might be better off doing it this way. So let's instead, we already used this equation. So let's instead use this equation. We're going to solve for, we're going to sort of rearrange for T1x. So, oh wait, oh, that goes there. And then, what do we get? So this is T2x, so this is mv squared over L cos theta minus T1x and let's see, what else can we do here? Okay, I think we can, right, we can take, right, okay, so we can rearrange multiple T1. Right? Kind of get rid of T1 in every case. So T1x, we can kind of use this, which was T1y, and we end up seeing. That over tan theta.
You gotta work like a slave to live like a king. For the money you bring, the power you swing. You gotta work like a slave to live like a king. For the money you bring, the power you swing. You gotta work like a slave to live like a king. For the money you bring, the power you swing. You gotta work like a slave to live like a king. For the money you bring, the power you swing. It ain't all about the money, it's all about the mind severe planet. Organized where you standing on the spear of humanity and gradually read the blueprint so you can illustrate with knowledge of self. Everything become minimum. The bill you're playing excluding the lame material gain to keep you stagnated if you try to play the game.
Ratio
leave it alone so you can ride high. Read the fruits of labor when you're thinking with your third eye. Stand firm, earn and learn so we can reign for longevity. Burn poverty with some properties, paradise upon this earth where we do reside. To make mansions, all we have to do is enterprise mentally, physically, or we'll follow. Make a change.
Okay, let's just go back to doing two equations, kind of two unknowns, and then we'll get to the ratio there. So here, so we had T. This will be able to rearrange for T1x and then sub it in. So that whole thing over tan theta. Okay, got it. Okay, so let's say mv squared over L cos theta is equal to T2x plus, and then FG, which is really mg plus T2x tan theta all over tan theta. So T2x is equal to mv squared over L cos theta 2 minus mg of tan theta all over 2. Okay, and then that
you gotta work like a slave to live like a king. That's why I'm out here steadily doing my thing.
that I wonder if we can then kind of put that back into this and get T1. That will just, yeah, that should work. So let's do it. I know this is kind of crazy. Seems like the only way that this would work for my brain. So whatever. Sometimes it happens that way. Okay, so let's go on to that. Okay. So let's say now mg plus mv squared or is that going to just do that for us? Hard to tell. Okay, we'll see. mv squared over L cos theta minus mg tan theta all over 2 that times tan theta is equal to, and let's just maybe say this whole thing over theta is equal to 2x, and then we could do the ratio of these two things. So mv squared over L cos theta minus mg tan theta, that over 2 all over mg tan theta Okay, interesting. So it's so that works out to be something reasonable, right? Halves cancel. So it's like mv squared over L cos theta minus mg over tan theta all over plus mg tan. I know it's ugly, but we got there. Okay. Hello? Sorry. Okay. So let's do it. It's down here. Bathroom maybe. So we can get started on this part of the question. So we can actually answer this question, right? How would the mass affect this? This is canceled. Mass is canceled in this equation. So you say it wouldn't.
But in order to blow up, you must sound like shit. You must have a gimmick, you must have an image. But the dirty science crew will take you to your limits. Cause they be loving me, they be loving me. I'm representing why you very loving. I'm representing why you very strong and live. Don't need to fake the moves, don't need to fake the moves.
I'm sure this kind of has a nice common denominator, but let's just it does kind of like look nicer in some way this way. Okay. For what speed of the ball does the tension force on the lower string vanish? When is it equal to 0? Okay. So I'll maybe leave you with this. I'll be right back. Okay. When does it vanish? Does it vanish?
To maintain my sanity, technology, the devil's tool to genetically fallacies, fallen angels oversee human casualties happen more rapidly through drone warfare. The red scare flag, you water and air chances are rare to survive. So prepare radiation fallout, mental bondage. She scream a call out for Jesus, grabbing your cross, begging and pleading for deliverance. No man is innocent, for the blood of Christ was never spilled. It was Judas on the crucifix. For history's foul, a Roman Empire running wild. The devil himself control the world. You wonder how to escape this hell on earth. FEMA plotting my demise, baptized in European culture is a curse. Now I'm stuck in between two worlds. 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 Throughout the canals of life, I journey from triple night. I robbed the ignite, cells that don't react right. So at mid-flight, I got caught up with the hype, masking to the core, but sometimes look like a dyke. You won't get it right. So I say feel overtly feminine. For if there's truly power in my melanin, then why do I need psychotic medicine? In largest doses of religion, reiterate our allegiance to electron-based entities who aim to annihilate, corrupting my environment so they can properly gestate. Unholy balance that simply creates the worst hell. If we a team, let's drop, or I go for duff. Another shattered memory, martyred photo on the shelf. I'ma break out of this crate that strives to denigrate the glow of my mind state. Even though my fate predicates my being great, it all seems pretend as my elements apprehend my confidence and concave my spiritual lens. Fast to be cleansed, but that won't be the end as I transcend most of my peers, yet I overlove my people. So when self asks to others' aid, disappointment be the sequel. A deity among men who follow a man, and as my glow expands and yank me back under the hand. Invisible, but his partiality leaves us divisible. If the doctor says ye are gods, it pertain each Nubian participle. Yet some deny the article, for they haven't mastered their particles, intimidated by my command of molecules. So now I'm equivalent to their ridicule. It's pitiful. I let toxic saliva anoint my holy temple to the point every block trembles when the bass kicks and ride over the cymbals that mean nothing. But thought pattern is more important than line for line recital. My vital stats improve as I eradicate my captivity in the middle state. Now I'm stuck in between two worlds. 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 In between two worlds. Wink, 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 wink. Between two worlds. Between two worlds. Between two worlds. Between two worlds.
That about does it for today. You can hear
Bring it on! You can set my mode to whatever, or simply pay the penalty for walking this endeavor. My observations on your alter egos will let you penetrate. Demonstrate how you fucking form when you fake. Bring it on! You can set my mode to whatever, or simply pay the penalty for walking this endeavor. My observations on your alter egos will let you penetrate. Demonstrate how you fucking form when you fake. Bring it on! You can set my mode to whatever, or simply pay the penalty for walking this endeavor. My observations on your alter egos to let you penetrate. How you fucking form when you fake? Bring it
Even be
on!
getting more graphic. Neo Geo 32-bit computer chip piece slip between my lips and then I'll spit it out, go ahead, spit it out. That itty bitty style you uptuck. Better believe I butt fuck MCs from the rear of the picture stuck up. It's my terminology that strikes the mind and puts the speed apart. You know the many styles I choose will boost from the start. I flow awkwardly, that's awkwardly. I flow that's to the rhythm. Incisions are made into the brain and then I begin to give them a lobotomy. Follow me, I'm shaping your brain.
On the track.
Give me the PH, give me the AR, give me the OA, give me the HE Pharaoh. Crazy points and tip arrows are hitting you from all directions. You cannot dodge, I manage to dislodge them from the point in which they are connecting. I am selecting. No, style, pow, of MCs who try to get fuck, wow. Fuck that. When I'm in a state of mind, I'm innovative. Never been afraid of rocking the microphone, I'm prone to be eliminating. Cling when I sing a song of sixpence, if it makes sense, then sing along. Cling along to my nuts, if you got guts, then bring it on.
Bring it on! You can set my mode to whatever, but simply pay the penalties for walking this endeavor. My observations on your alter egos to let you penetrate. How you fucking fall when you fake? Bring it on! You can set my mode to whatever, but simply pay the penalties for walking this endeavor. My observations on your alter egos to let you penetrate. How you fucking fall when you fake? Bring it on! You can set my mode to whatever, but simply pay the penalties for walking this endeavor. My observations on your alter ego will let you penetrate. How you fucking fall when you fake? Bring it on!
Consider me the epitome of rhyme through the text. Execution is parallel to none with the inception of the organism. Mind telepathy can't be dismantled, so stop sweating me, getting me vexed. While outdated raps get trampled. V5 folks, sense of elevation show that I'm ahead of your time. Behind a dope rhyme, ripping shit up at prime time. I'm up to this prime time material, imperial wizard, a vocabulary havoc. I eat MCs like cereal, that's soggy. Milky skills like Mr. Miyagi. When it's fog, at least groggy spits remain. The rappers in the lobby, the hobby. Ow, rip your nick, shit is sick. Quick, get your crew before I do something gory till you're quite futile style. Finish your raps, you wax, Simonized into the fifth dimension. Orange is the football, never typical stand attention. I'm mystical, rips it till the power blows. Those shows to compete, we delete them. Observe defeat, descending down from above. Get your hit, just like your picture you. Victorious, the story is your core.
Bring it on! You can set my mode to whatever, but simply pay the penalties for walking this endeavor. My observations on your alter egos to let you penetrate. How you fucking fall when you fake? Bring it on! You can set my mode to whatever, but simply pay the penalties for walking this endeavor. My observations on your alter egos to let you penetrate. How you fucking fall when you fake? Bring it on! Whatever!
Seashores to the Pacific seashore. Pleased to meet your acquaintance, now meet your match. When spots are blown with lyrical C4 cuts and scratch, the detonator got you feeling for more. Steadily, like I told you before, the melody be as deadly as steady be being broke. As a slit throat, as a bitch butt naked with a mink coat. Walking through Harlem, it ain't no problems when the troubleshooter's here to solve them. Hip-hop has been my life story. Hip-hop has been my life's glory. If you can't rock, then get up off me. I use your dome piece as a trophy. Derek Strong rhymes dopey. Y'all sucker motherfuckers know me, and knowing me is half the battle. Yo, and since you knowing me, then you knowing we have to battle. Yeah, duck behind your bulletproof shield, hater.
My mic is the silencer to quiet your amateurs. Creeping on your camp like tarantulas. Infiltrate without tripping alarms. Cutting niggas' gizzards like Hillshire Farms on this event horizon. Exercising, cunning like the jackal. Master of disguises, full of surprises. They got him shook and frantic. Scheming on your team like
Alright. Alright, we're back. So let's just finish this question here. So, for what speed of the ball does the tension force on the lower string vanish? When is it equal to 0? Well, when is this fraction? Because remember, it's T2 on the top, and so that's what we labeled as the bottom one. So when is this fraction equal to 0? Well, when those two are equal to each other, right? So when v squared is equal to L cosine of theta times G over the tan of theta. Well, cosine of theta over the tan of theta is really this. So then that's cos of theta over sine of theta, and then there's another cos of theta, so it's cos squared. So cos squared theta over sine theta. L times cos. Okay. Another thing we could do is turn this into 1 minus sine squared theta. Okay, so that's the speed where those are equal to each other, so they're equal to 0, right? So, sorry, like the subtraction of them is equal to 0. Okay, I think we can actually maybe end things there. How does that feel? Let's do it.